This practical is on verification of Snell's law. Do you get it?
Yes.
And that is a refraction. What do you understand by refraction? Refraction is a change in direction of light as it travels from one medium to another medium. Do you get it? Now, as you can see, this is the diagram for the experiment. This place is the air medium. This is the glass medium. This is also the air what? Medium. Now, this is incident ray. This one is refracted ray. This is emergent ray. This R here is angle of incidence. This R is angle of refraction. But this line is called normal. Do you get it? Incident angle is the angle between the incident ray and the normal. Angle of refraction is the angle between the refracted ray and the what? Normal. Now we place our block prism on the drawing board. We have the apparatus for the experiment. We have the rectangular glass prism. We have the drawing board. We have optical pins, and we also have A4 paper or drawing paper. So after that, we place the block on the paper, and we place the block on the paper. We now measure the angle of incidence. Our first angle of incidence is 20. When we measure 20, we view through this point. And when we view through this point, we find out that where these two pins, pin 3 and pin 4, will be in a straight line with pin 1 and pin 2. So when they are in a straight line, we join these two lines to get the angle of refraction. So when we get to get the refracted ray, and we now measure the angle of what? Refraction. So we are going to use the same method for various values of angle of incidence. For first angle of incidence, what is the angle of refraction? For second angle of incidence, what is the angle of refraction? Then we take the sign of them. Snell's law, what does it state? Snell's law states that the ratio of sign of angle of incidence to the sign of angle of refraction is a constant. That is, Snell's law said that sin I over sin R. Sin R is a constant. What is this constant? This constant is the refractive index of the material you are using, and this material is a glass prism. Experimentally, it has shown that the refractive index of glass is 1.5. So our experiment should be heading towards 1.5. If at the end of our experiment we didn't get 1.5, that means something is wrong somewhere during the experiment. So let us conduct this experiment and see how we can verify Snell's law. Okay? No, so let's start. The angle of refraction using your protractor. The angle of refraction using your protractor. The angle of incidence is 20. Your angle of refraction is, I think, is what? 13.2. And when your angle of incidence is 30, you got 19.5. And when this one is 40, you got 25.4. And 50, you got 30 point this. Then how do you get this place? How do you get this place? You say sine 20 to get this, and sine 13.2 will give us this. Sine 30, I think that gives this, and sine 19.5 gives you this. So these are various what? These are the result of a candidate, a student, SS2 student. So this is your own result, and we have different results for different students. Can I see your own results? Let me see. Okay, this is your own results. Okay, for your angle of incidence, you got 13.2. 13.2 the same. Okay, for your angle of incidence of 30, you got 20.1. Maybe it's a slight difference. Okay, it's okay. These are the result of the experiment. Okay, now let us plot the graph and see the behavior. Okay, let's start. Okay, now this is the graph. I have to come close. This is the graph of the experiment. As you can see, we plotted a graph of sine I against sine R. And the graph of sine I against sine R is a straight line graph that starts from the origin. As you can see, it's a straight line graph that starts from the origin. Now, the slope of the graph gives us a constant. And the constant, this constant 1.5, is the refractive index of glass. That's the ratio of sine of angle of incidence to the sine of angle of refraction is a constant according to Snell's law. So this one now has proved that we have verified what? Snell's law using the experiment. What verifies Snell's law is a straight line graph that starts from the origin, and our slope that gives us the refractive index of the glass. That means the experiment is in order. Do you get it? Yeah. So that is the end of the experiment for today. So next time we'll meet. Thank you, sir.